Hi everyone, I'm Martin and welcome to another great edition for Astronomy for Beginners. Now today I'm going to do you a video guide on how to make this fantastic device. Now this is the electronic focuser for the Skywatcher 127 Mac. Now if you have ever noticed that if you try to image planets, look at the planets or the moon in particular, or taking a live video shot of them, they can be really tricky, and so tricky that if you try to focus the images it can be very difficult, and the planets are moving about like crazy. Even on a sturdy mount like this, which is more than ample, EQ5 mount, no matter how much you keep it steady, if you start moving the focuser around, you start to get a lot of disturbance. In particular when you're trying to focus. So yeah, it can be really quite tricky to achieve focus. Now achieving the focus will eliminate, if you get sharp focus, you'll get the best possible images available. I'm not going to guarantee you're going to get the best possible images, but focus will eliminate a lot of the problems and you'll get really good detail on the planets. Now if you take a look at the last few nights, I was taking a NAVI file recording of Venus, and what I'm going to do is I'm going to show you video shots of with this electronic focuser and without the focuser. So now we're going to try and focus the Maksutov using the manual focus. Okay, so no electric focuser fitted. Alright, I'm just going to compare the results. Now bear in mind, I'm using my hands carefully, and as you can see I'm all over the place, and it's really hard to get it all focused. Again, you've got to wait like a few seconds to let it dampen out on the mount. Obviously this is using high modification. Alright, 3 times the modification on the camera, and as you can see, if I focus here now, it's dancing like crazy. Okay, and you can see how difficult it is without the just using it manually. Alright, and again, it takes a lot of practice and all that to try and get this just right. So again, using the electric focuser, we're going to see and compare the results with the focuser. Right, and see how much improvement the electrical focuser has made. So now we've got Venus. I've got it set to the camera at ISO 200 and exposure time 800. It's twilight now, and as you can see, this is at 3 times zoom. And I'm just going to demonstrate. I mean, this is quite high power, and I'm going to demonstrate how good this electric focuser is. As you can see, I'm out of focus, and look at that, really razor sharp. Okay, I'm out of focus, in focus, super sharp. And there you go, there's the image of Venus. Obviously I haven't got my tracking set, but it just shows you how much of improvement that has made by fitting that electronic focuser. So, what do you reckon, guys and girls? Very impressive, isn't it? This modification has helped dramatically and achieve really good focus, very sharp focus, without any undue movement. Because as we're using high modification and all that, Maksutov doesn't help either. You can achieve, and focus plays a huge important part of getting sharp images, particularly when you're stacking. It's very important that you get that focus spot on. Now the good thing is that this electronic focuser, you can buy in a lot of astronomy shops, but there aren't many for this particular branded telescope. Now I have seen 1 or 2 examples in a lot of good astro shops and online, and there is one brand that I can't mention, is I've seen for about 165 to about £170. Now to me, I've not seen any other brands, but this particular brand is, I think, is quite expensive. And I found another way that you can make this yourself. Okay, and please undertake this. Now, again, I've looked into it, and the most cost-effective way is I purchased this Skywatcher electronic focuser. Now, you've probably seen this in a lot of videos, or you've seen this online, that the Skywatcher, I think, is the best option. Now, this device includes the control box, slow speed, it's got the electric motor, and it can fit on a lot of Skywatcher brands. However, there is nothing that you can adapt to make this fit on the Skywatcher 127 Mac. So, again, I found it a much cost-effective way to purchase this device. This costs around about £40, between £40 to about £47, brand new. I managed to get this second-hand for about £20. So I was going to make this device myself, with making my own box, my own electric motor and all that, but it's not very cost-effective. And it's actually far cheaper to buy this assembly first. The only difference between my project is the drivetrain and the bracking system. So with this electronic device, I think this is the best option. There are many people that's undertaken this project before. I mean, this is not new. The thing is with this project, please feel free to undertake it. It's well worth the money. Okay, and again, it's far a lot cheaper to make this project yourself than buying a ready-made system, which is actually very, very similar to this anyway. It's just that the gear system is slightly different. So if you're interested in this project and you want to do this yourself, okay, keep watching and I'll take you through it. To begin with your project, you're going to need a few parts. These are the S2M 160mm in width, 2mm pitch, and they're 80 teeth CNC timing belts. Okay, they're really tiny belts. Now these are designed for a 3D printer, and it's a GT2. Basically that's what it means. It's the width of the teeth is a GT2 teeth. Or I might order some online through Amazon for about £7.71 for about 5 belts. So it gives me a few spares in case one snaps. Okay, so I've got spare ones. Now you can get bigger belts, but I won't recommend you getting the GT2 timing belt, which is much more than 200mm in width. Okay, so the width is basically the entire outer circumference of that belt. So 160 is probably ideal for my project. But if you get a longer belt, it just means that your focusing device, you might need to make your anchor bracket, your tensioner bracket, just a little bit longer. So I've actually did a lot of maths, I've worked it all out, and 160mm in width is ideal. Again, the belt is 6mm in the actual thickness, okay, the actual width, okay, so it's not too thick. So you can get these through Amazon, or any electronic or any modelling shops out there will sell these at a good price. So I will provide the links there. The next component you're going to require is this. This is a GT2 aluminium. Okay, so aluminium made. It's a timing pulley. Again, it consists of the GT2 teeth, and there's about 20 teeth on that. And the main thing we're concerned about is, we're not bothered about the diameter as such. All we're concerned about is it needs to be 6mm in width, so that it's just enough to feed the actual timing belt on there. And the teeth, because it's a GT2 teeth, these will mate in perfectly, like so. The other thing to be concerned about is that it needs to be a bore of 6.35mm, okay? And again, this is crucial. This will become apparent when we fit this device together. This is a single piece. You can get them in double packs, and you usually can find them in a lot of 3D printers. But I managed to get one, a single one on its own, and you do get the actual Allen key as well, so that because it's got tiny bolts, Allen bolts in there, so you can actually clamp down to a shaft. Again, this cost me around about £2.08. It's not expensive, but again, I got aluminium because it's very lightweight, so I'm trying to make this focusing device lightweight as possible. Okay, so I don't get any balance problems. As I ordered on Amazon, I managed to get a bigger pulley system. And again, this is a 40 teeth. It's a Anycubic XL type. It's aluminium again, it's all made out of aluminium. Pulley, because we're main concern is the actual bore size. It needs to be 12mm all the way around. Okay, this is designed to fit on a 6mm belt. Okay, and it's GT2 teeth. Now, because I've ordered this on Amazon, you only can get them as a set, but that's not to worry, because again, if components get damaged or any other way, you've got replacements. And again, this set comes with 2 Allen keys as well, together, alright, as part of a set. And again, these are from a 3D printer, but these are ideal. They're very lightweight. They don't even weigh about 40 grams. In fact, they probably weigh about 20 grams at the most. So they're very lightweight components. That's part of the drive belt. As you can see here, as we put this drive belt together, right, you can see already what the mechanism will look like already, and this is what we're trying to achieve. Now, the reason why I use tooth belts is because once you get the tension, they are relatively quiet, so when you operate the focuser aid, these will be very silent. And the good thing is, if you reach to the focuser, say like at the end, usually if you get to the very end, there's dead stops within the focuser, and usually if it reaches that dead stop, more likely is I did try. My initial idea was in the video. Later in the video, you will notice there was gear drives. I tried to do a gear type drive, but the actual gears didn't work. So when you look at the video, there may be some discrepancies of different gears. Don't worry about that. These are the correct ones, because I've done a lot of research. So these are the correct components to go for. So the gear type didn't work. That was the first prototype. So these are basically the second modification. Okay, so I did a lot of trials, and these actually worked out the better option. And the good thing is they provide a really good traction. Okay, they're very quiet, very lightweight, and when they reach to a certain dead stop, all right, it's not going to damage the actual focuser. Okay, the actual focus mechanism. It's more likely to snap the actual belt or slip. Okay, so if it does slip, you reach to a dead stop. Okay, at the end of your focuser. So they're really good design. Now, if I had the gear type, they're probably more likely to damage the motor or damage the focusing aid. So I scrapped the gear type altogether, and these actually worked out better in the long run. So if you see in the video and you see the different types of gears as I proceed further, don't worry about them. Now, the whole idea is I did waste a lot of money to try and get this modification to work, but at least one thing now is, now you'll be able to undertake this modification, order the parts, and save money in the process. Okay, I mean, I've gone through a lot of trouble and a lot of hassle trying to make this video to make this modification work, but this time I've got the correct parts now. Okay, I've just sent off the old parts now, which I didn't really need, and these are the correct ones to go for. So that's basically the actual drive, what it looks like. So the next part you're going to need is this. This is a sheet plate of aluminium, 2mm thick by 200mm by 200mm square, and again you can use a little bit less, 200mm by 150mm, just to reduce costs. You're going to need this set. This is basically the Skywatcher focusing electric focuser kit. Now I got this second hand. I got it for about 20 quid. Alright, that's what it cost me, but to buy brand new usually costs between £40 to about £50 maximum. But usually you find these brand new for around about £44–45 normally in the UK. And again, the kit comprises of a lot of stuff. You know, you got your, it's got the instruction manual. Okay, it's all installation adaptation. This kit is only useful for like the 1¼ or 2" focusers, or some of the basic Skywatcher focusers, particularly the old blue tubes and the Dobsonian white tube Newtonians. It does fit some refractors like the short tubes and all that. But however, we're particularly interested in this kit alone because I think this is the best electric focuser you can buy cheaply for not much money, and you can do a lot of stuff and adapt this device to a lot of Skywatcher telescopes. Now the one thing we are particularly interested is, you know, you've got a variety of things, is we've got the electric motor. It does have its handset and its cable. Okay, now I was going to make this device like my own sort of controller and motor, but it works out cheaper to buy this set complete than it is if you're going to make your own controller, your own motor and so forth. It's actually a lot cheaper to buy this kit complete. Now you can get a lot of electronic focusers, but nowhere near you can buy anything as cheap as this set. And the good thing is it's got a 9V battery inside this hand controller. It has a fast and slow speed. It's got its directional controls up and down. Okay, so it's relatively simple, it's cheap, but it's also very good quality as well. And again, it does have its own little brackets inside. Okay, but again, we can make this electric motor fit into the Skywatcher 127. Now this does fit a lot of equipment, a lot of telescopes, but one thing we are particularly interested in is we're going to try and convert it so that the 127 mat will run off this electric focuser. The good thing is it has its own little, all these little tools that you have. So it has its own issued, it looks like a 2mm and a 4mm Allen keys. Those are the ones that are going to be very useful to have, especially when we're installing the electric focuser onto our telescope. And again, you know, there's a few other items in there. Okay, but again, a lot of the stuff in here we're not going to use. We're not going to use the brackets, and again, we're just going to use these items. Okay, that's all we're going to be using. Now it sounds a bit crazy, but what we're going to do is, with the issued equipment, use the 4mm Allen wrench. We basically want to crack off this Allen bolt, okay, alright, and we want to take off the actual this part here. Now this is very tight, alright, but because there is an O-ring that holds it in, alright, it does take some time to pull it out, but it will come out. Okay, just a bit of gentle persuasion. Okay, jiggle it about. Okay, like so, and then it just pops out. Okay, we don't need this item. This item will just get discarded. Alright, and save it within the box. Okay, just in case we want to fit this electric focus to other telescopes. And basically, we just want these items by themselves. Okay, so that's all we're going to be using on this kit alone. So we put this to one side. Again, this kit, the electric focuser kit, is not too heavy. 270 grams it weighs overall. So right, so it's not completely heavy, but the motor probably weighs about 90 grams. So, and then a sheet of neoprene sponge, which is a foam rubber sheet, okay, 200mm by 200mm square, okay, and it's 1.5mm thick, okay. So you're going to need a sheet of that, and again, it's got adhesive backing, so you can cut it into shape, stick it onto your project and all that, and so forth. Okay, so you need some of those as well. And finally, you're going to need two metric free 6mm long thread, okay, 2 screws for them. Right, so they only cost a couple of pence, so you just need 2 of these. You've got a Phillips head on there, so you can use a Phillips screwdriver. The tools you're going to need as required is, first off, you don't need a lot of tools to do this awesome project, but you're going to need something like this, some marking devices, which is just a little kit where you can mark out using squares, ruler and all that to measure up your bracket. Okay, so it's very crucial you've got some kind of marking devices, alright, so you can measure it up, alright, and draw your engineering drawing. Again, permanent marker, which is a fine tipped. Alright, this is good for when you're marking up your material on your aluminium plate. Okay, this is really good for that. Then you're going to need a set of screwdrivers, ideally a cross point and a flat point. Okay, so you're going to need some screwdrivers. When you're marking up your work, there are a few holes you need to drill. Okay, so you're going to need a center punch and a hammer, so you can mark out the areas of your project. Also, the hammer plays particularly useful when you're trying to bend the bracket as well. But I'll show you how you do that on the other video. Again, a minimum of using a hacksaw, okay, with a metal cutting blade. Okay, this is the bare minimum, a junior hacksaw. Ideally, if you've got power tools that can cut through sheet metal, okay, ideally use them because they're going to make the job a lot easier. But minimum of a hacksaw with a cutting metal cutting blade to do this. It's going to be hard work, but power tools make it a lot easier. With the project being like a very complex design, you are required to cut down the material. Okay, you're going to need a set of needle files, like a round needle file and a flat needle file. Okay, because of the adjustment bracket, you need to do a lot of filing to smooth it all out so it all fits all together. Okay, and again, using a coarse file itself to remove a lot more material on the aluminium plates. So there's going to be a lot of filing. Okay, so you're going to need those kind of tools. As I described with the center punch, you're going to need a drill, okay, like this one. Alright, you just need an electric drill, and you're going to need a 2mm and 3.5mm. Now, if you can't get a 3.5mm drill bit, you can use a 3mm drill bit, but ideally a 3.5mm drill bit. The 2mm is good for doing the center holes. Okay, so you're going to mark out the material, okay, before you start using a bigger drill bit. So this is good for marking up your hole, drill a hole into your bracket. Okay, and then this is going to be the actual size of the 3.5mm diameters as shown in the diagram. Now, because you're using a 3.5 drill bit size or 3mm drill bit size, you're also going to need a tap and die set. Now, this is a tap set. This is part of the kit. Again, what this is, this is like a 4mm tap, okay, and what this does will cut out a thread within the bracket, okay. So again, you're going to need one of these. You can pick them up for not much money, okay. So you need a tap and die set, ideally with an M metric 4 thread and then a tap as well, minimum. And last but not least is you're going to need a little bit of grease, which is lithium grease, okay. This is described in my last video guides, okay. Fantastic product, okay. This will lubricate some working parts, okay. So you're going to need some of this as well. Now, with my engineering designs, as you can see, my purpose-built bracket for the motor and the bracket, the main bracket that attaches to the telescope. Now, as you can see here, these are what I've measured up exactly, and they should fit properly onto my Maksutov 127. Now, as you can see here, I've already marked this out on my sheet of aluminium plate. As you can see, there's a bit of excessive material, as you can get away with 200 by 150 millimeters if you want. But if you make a mistake, at least you've got another spare room here to just remark it again and then start again. So that's the reason why you can order just a little bit too much material. But having too much is better than too less. So if you make that mistake, you're going to have to reorder it, remachine it. So again, I've already marked it out. As you can see here, these diagrams here, these engineering drawings, you can actually cut these out. These are exact same scale. Okay, so if you cut them out, I find it very easy. Once you've got them all measured up, you can actually cut them out, place them in position like so, and then just redraw over the top of the sheet metal, okay, so you get the perfect sizes. As you can see closely into the sheet metal itself, I've marked out the center holes of where I'm going to drill my circles, okay, particularly the 46mm diameter and the 12mm diameter. Now, obviously you can see here, these are marked centralized, okay, so I can get my dimensions pretty much accurate. Again, if you refer to the other video guide, you can actually find out how to mark out the dead center of these squares here. Now, one thing I need to point out in this drawing itself, you'll see here is like a fold line. Okay, this is basically where you're going to fold the metal across. Okay, this will become apparent once I fit the bracket over, okay, and you'll get to see where that fold line is. Now, this is not exactly the true fold line, it just depends on your model of your telescope and all that, and you will get some access of a little bit here. So if you do that, if you do get a little bit of access, you can cut that piece out once you've got that fold line. This is very crucial, this fold line, because once this is in line with the focuser shaft and this is in line with the eyepiece holder, okay, once that's in line, alright, then this fold line here, you'll bend the plate backwards, okay, onto the tube. Okay, so you're not going to damage the tube anyway, because the sheet metal is very thin, so you can actually bend it by hand. So again, this depends on where that fold line is going to be, and if you do get a bit of access, you can just cut this piece out, okay, as necessary. Also, there are other fold lines here. These fold lines here, either side, will actually bend round the tube itself. Okay, so there's going to be a slight curve. Basically what this plate does, as well as being attached through the eyepiece here, or eyepiece holder, this is clamped on that side, but it also prevents the actual plate from rotating. So when the focuser mechanism, electronic focuser, is in operation, this acts like an anchor plate. So this anchor plate here, because it's slightly curved along the tube, this will act upon against the side of the tube, so prevent any twisting on the bracket itself. So that's what I've done with my design. Now, people have fixed theirs with different methods, using external brackets on the dovetail and all that, but unfortunately, because of my design of my Maksutov, I can't do that, so I have to do this routine. Again, like with all Skywatcher telescopes, every telescope that you buy are all sort of not exactly the same. Okay, some have different variants than others. Now, as you can see here on this Maksutov, alright, you see that on some Maksutovs, the actual focuser is actually at this point here, but on mine it's not. But on this one, it's usually, most of them are usually at the bottom, in line with the bracket and the dovetail. Alright, but that's not the case with my variant, so unfortunately this is a different method to do it. But again, this bracket itself is universal, so it will fit on any Maksutov 127s. Okay, and it doesn't matter whether you twist the telescope in different positions, this is still the same fitment. This will fit exactly the same. Okay, so basically this acts like an anchor plate. And the good thing is you don't need to worry about the marking on the tube or denting. Okay, as I show through the video guide, you will not damage your tube if you follow this video guide exactly. So this is the second part, the component of my design for the actual tensioner. Now basically this holds the electric motor, and have you noticed is that it's a little bit difficult to draw this, but one thing I found easier to get the actual fitment correct as you want. Now the actual size and dimension is okay, but when you cut this sheet of metal, okay, it's going to look like that. Okay, again, this fits perfectly. Okay, exactly what I want. Alright, and now there'll be a lot of filing. You have to do a lot of filing, a lot of cutting around. Again, I advise you to use a jigsaw that has a metal cutting blade, so you can cut the metal out as per on the design. And again, you can use the hacksaw and do a lot of more filing. Okay, so it does take a while to make this component. I've drilled out my 3.5mm holes either way. Now, one thing I didn't describe on the actual diagram is I don't have the further enough dimensions. Okay, now what is it's easier to explain is I've got this motor here, and basically what you notice is here is that's the metal drive, that's the actual drive shaft itself. Now, because of the design, I find that it was easier to mark the holes perfectly. So basically what I did is use a Phillips screwdriver, take off the actual screws. These are tiny little screws, and you take these off. Okay, these are very tiny screws, and to be honest with you, I don't find them very sufficient to hold, and that's why to hold the actual bracket, and they really are tiny. And really cheaply made. But however, what I did is I took this plate off, and to get the exact hole markings you need, I found it was easier if you place this over your design, over your engineer design, and then you just basically line up and just mark up the holes. Okay, so you just mark up the holes like so. Okay, so you line it up, alright, and then you just get yourself a pencil and you just mark off the holes, alright, and then you can mark off the circle part here. Okay, and that'll give you the exact hole markings and where to file it off. Okay, and that's how I managed to achieve that shape. Now with the actual tensioner, right, this motor is going to mount on here like so. Now, depending on the spindle sizes, you can have the actual tensioner on this side, okay, and you can, and I always put the actual metal part as well as extra security, right? You can mount either way, all right. It just depends on your pulleys, okay. So you basically what I do is just line up the holes with the original plate, and then you can put your line up holes on that. Now it's a bit fiddly, but as I described in the video, you get your bigger screws. Alright, again, these are metric free, they're longer screws. Okay, so because you're compensating for the extra thickness of the material, plus they are better screws as well, so they're better than the standard screws. And basically you just line up the holes. Okay, you see these little tiny screws here where the screws used to screw. You basically just line them up like so, and basically you just want to locate the holes first. Okay, then grab the other screw. Right, so that's all. So now that's screwing in. Okay, be careful not to put them at an angle, or you cross thread those fine threads. Okay, you don't want to do that. And all you do is just nip them up. Don't need to be too tight. And that's quite strong now. You put the original screws back to one side, and then you get your 20 teeth pulley wheel. Okay, and you see this flat face here. Now if you notice on the drive there's like a flat face. Basically you want this pulley, okay, you see where the Allen screw is, you want to line it up to the flat face. Okay, so on that flat face you line it up and it should slot inside like so. Okay, and then with that get yourself the Allen key. Okay, and then you just screw in, just nip it up first, tighten it up, like so, just nipped up. You can actually tighten up the other end as well for extra security. So there's another hole here, so once you've tightened that up you can also tighten this part here. Okay, and it just needs to be just nipped up. You don't need to be too tight. It's got two screws there and it's enough to hold it in place. Alright, and that's a good permanent fixture there. Okay, that's not going to come off. Alright, and there's a little bit of a free play, but that's not to worry. So again, perfect, good fit. Now you can see now that is your tensioner and your electric motor assembled together, and your spindle. So we take our eyepiece holder like so. Depending on your model, you might have the 2" format or the 1¼ inch. With mine, this is a modification that I did. Okay, so I'll take that off, and I have to take off the scat thread adapter. Okay, so I'll take the ring off and I take the O-ring off. Okay, so make sure you take the O-ring. Then I use the issued Allen key, which was provided with the focuser. The screws fit perfectly, and they should slide off like so. Now just be careful not to get grease on there, or see I've removed some of the grease anyway. This is black grease in there, and there's also a washer, okay, a fibrous washer in between that part there as well. Again, leave that in, you don't need to remove it. If it does pop out, just push the washer back in its place. Okay, like so. So after you've done a lot of filing and cutting, this is what the plate should look like. Now don't be too bothered about having a perfect circle for the 46mm diameter. The main thing is you want to try and get it so it fits over the eyepiece holder. Also make sure that the hole for the 12mm hole diameter is drilled through, and as you notice here, I've cut 2 slits there. Now what we're going to do is we're going to fit the bracket over. Okay, it goes this way. Okay, and we're going to fit it, we're going to move over, and we're going to fit it over like so. Right, so that should just fit nice and flush. Now the reason why you don't want to tilt the telescope down is you want to fit in the gear first over the brass spindle. Okay, so we're going to fit it over for the time being. Okay, we're going to tighten it up. Now the reason why we're going to tighten it up is we don't want the spindle to fall into the tube. Okay, we don't want that. Alright, you want to keep this tube horizontal. So we're basically going to tighten this up. Yeah, just nipped up, that's all you need to do. Now it's safe to tilt the whole tube on its top. Okay, so now we've got our vertical position. We now know that this is secured, this is not going to fall down, the actual spindle. We then place our adapter. Now if you've got 1 1/4 inch, the 1 1/4 inch will just fit directly on top of that. Okay, so you fit the 1 1/4 inch nose piece. However, I have the 2-inch format. I also have to use the SCAT to Mac adapter. Okay, so I screw that on top like so, and I'm just basically going to just tighten it up just a little bit. Okay, so what I'm going to do is just making sure that this gear wheel is free to rotate. Alright, and I just tighten that up, okay, like so. Alright, and that gives me a little bit of stuff to play about with. Then I'm going to screw on the 2-inch nose piece. Try and minimize any dust from getting down the tube. Okay, okay. Now what we're going to do is we're going to carefully try and bend this plate back using a bit of force. So again, you can really put a lot of pressure down there, and then you just want to bend this plate in. So you keep bending it. Alright, if you've got a bit of a fault line, don't bend it too much. What you could do, alternatively, you know, because we want to make sure we get this perfect, we'll find out where the actual bend is or where it's situated. So we'll tilt it around. Alright, and you can just see here where we need to bend. So what we'll do, because we don't want to add too much pressure to the tube, we just draw a rough line using a marker, okay, like so. Alright, and just mark that position. Okay, so we mark that position there. So basically what we could do, we'll take the whole plate back and we're going to bend using a hammer, and we're going to bend it in a vise in a nice even curve. Okay, and that's what we're going to do. So we get a natural bend on there, so it'll bend all the way into once we've finished. We're going to take this off and we're going to put it on the vise and then bend it back. So we're going to keep it horizontal. Okay, when you're taking this apart, so take the nose piece off. And the adapter. Take the gear off. Okay, that should pop out. Okay, so that's safely now. We'll put the rest of the stuff back. Okay, keep all the dust completely free. So tighten it up. Okay, just try and minimize the amount of dust getting into the tube, and or prevent the drift from falling down as well. So now, because now we got this marking lined up, now we're going to go put it on a vise using a hammer, and we're going to bend that fault line across. Okay, so that's what we're going to do. So after a lot more work, a lot of twisting and bending using the hammer and a vise, now as you can see now I've got the desired shape I want to now. Now yours might be different to mine, everyone's design will be different on this, but what you're trying to do is, as you can see here, I've got the natural bend now. Alright, this will fit in place. I do have a little bit of excess material there which I'm going to cut off anyway, so I'm going to cut that off, file that down, and as you notice here, I've bent the actual little tabs there now, and basically what it's going to do now is I'm just going to fit this bracket in, and this should just slide in nice and easy, slots in just like that. Yeah, naturally slots in independently. Okay, so I can just put my attachments on and my gear wheel. Right, so now it's all mated together. Right, okay, it's all pretty good, that. So as you can see now, that's what it should look like. But basically what we're trying to do now, you can see now it's all bent round. Okay, nice and easy. If you desire to bend something a little bit more, like this gear wheel for example, you just re-bend it again. Alright, put a bit of pressure. I mean, the good thing about this aluminium, it's thick enough, but it's also easy enough to work with and to bend with. So again, just the only trouble with this design is you just try and work that material in. I would not recommend you start fitting your gear wheel and all that sort of thing and your motor, because what we're going to do now is we're going to take this bracket off. Alright, and what we're going to do is we're going to put the neoprene layer so we don't mark the tube, okay, before we start using the electronic focuser. So again, it's looking pretty sweet there. Alright, it's looking, as you can see, the main thing is this gear wheel. We don't want any chafage. Alright, so there's nothing rubbing on the sides of this gear wheel. As you can see, it's nice and smooth. And don't forget, there's no grease on that, so it's nice and smooth even without the grease. So now we've got our anchor plate made. Basically what I've done here, as you can see here, this is my anchor plate. I've took it off. It's now bent to the desired shape I want. One thing you have noticed at the back of here, because where it's acting against the actual telescope tube, I've basically marked out the areas to put my neoprene foam. Okay, so I've cut it into shape, and because it's got a self-adhesive backing, I basically, with this, I've just placed this foam onto this plate. So here now, this will give me a bit of protection, and it won't mark the tube. Okay, so it will give you some added protection, and that's the idea of this foam. Okay, so that's my basic shape of my anchor plate. The next step we're going to do is we've got our pulley like so. This is the one with the 40 teeth, and it's got the 12mm hole. Now it has to be 12mm because as you fit through here, okay, this is actually 12mm thick, this spindle, this brass spindle here. So you need that to slide over. Now as you can see here, in that spindle there is a 10mm recess. These Allen screws here need to go past towards the 10mm spindle part. Okay, so basically you fit it over the cross, slide it in like so. So we screw, okay, and then we tighten up the other one. Okay, so that's that tightened up, that's the spindle tightened up. Okay, you need to have a bit of free play in there. So as you can see here, I've just drawn a line which is halfway between the 20mm thick. Okay, so you just need to draw a line. Okay, and basically I'm going to place my crosses. Okay, so I'm going to, if it needs to be, if you want to hand with someone can hold that in place while you mark the position. So again, you want it at the maximum tension as possible. What you're going to do is you're just going to mark up where on the plate. So basically I'm going to mark up my holes here and here. it doesn't really matter where you want to place these markings. Okay, it really depends on your design. Okay, so you can mark up your holes like so, right, and that's the maximum tension. Right, I'm basically pulling this back and just lining up the holes where I think they're going to go. Okay, so that's what I'm doing here. So I'm just lining them up, and that gives me my position of where I'm going to drill my holes. Okay, it doesn't really matter crucial, because what I'm going to do is, once I've drilled these holes, alright, I'm going to drill them, elongate them slightly. Before I elongate them, I'm going to mark out the position where the holes are going to go. Alright, and I'm basically going to drill, I'm going to drill 3.5mm holes here, okay, and I'm going to thread these holes. Okay, so basically they're going to be threaded on this part of this plate, so when I tighten up the bolts, okay, they will clamp on and hold the actual tension itself. Okay, so that's what I'm trying to do now. So I've just drilled my 4mm holes. Okay, I've just marked it out. Alright, and what I'm going to do is I'm going to mark out the holes here. Before we do that, basically the reason why I did them as 4mm holes is with the actual focuser, the electric focuser from Skywatcher, I'm using the existing screws that you get with it, and basically what they're going to do is they're going to fit inside there like so, and they are going to screw onto this plate here, okay, like so. Alright, again, providing you're using the washers and all that, right, this is not going to mark the actual tube itself, right, so it should give me enough amount of tension. So what I'm going to do is place the belt, and we're going to mark out the actual holes we need. Okay, so that's my holes lined up. So now I've removed the plate, and as you can see is I drilled the holes and I used a M4 or metric 4 thread, and basically I just tapped across like so, and you know, it takes a while to just screw it in, but you just want to re-tap those threads, alright, like so. Right, and then once you've re-tapped it on both those holes, alright, you can just take that off. Alright, this will just unscrew out like so. Okay, and that basically gives you the tapped holes, right, you need on that plate. Okay, and basically now you can now screw these M4 bolts like so. Okay, and that's your bolt on thing now. So they're now tapped like so. What we do is, what I find easier is to install the pulley first. And before we do install the pulley, we put a little bit of lithium grease between the face. Okay, so you're just going to coat the face here, just on here. Right, so you're just going to put a film of grease on there. Right, and then once you put your film of grease, you're going to slot it onto the brass spindle. Then you're going to tighten up. Don't need to be super tight, okay, you just need to just nip it up like so. Alright, that's all you need to do. Okay, and just work that grease in. So we just move all the stuff out of the way. Then we're going to insert the 2-inch eyepiece adapter. Okay, eyepiece holder. Okay, we'll screw that back on. Okay, like so. As you see here, I have elongated the holes around about 10mm long. Okay, so we get our our bolts. Then we just line them up like so. There's no need to put any grease. Alright, there's no need to put any other grease in there, because basically you don't want any grease in between the plate. Okay, so basically you just tighten these up. Okay, before you tighten them up, you want to, so that you can just push this in and out. Because it's 10mm with play, we then place the belt over. Okay, and then you just, once it's bedded in, just put a bit of tension. Then using a screwdriver, pull. Basically what you're going to do, you're going to pull the motor away from the pulley. Okay, and you're just going to tighten these up. Right, and then just nip these up. Right, not too tight. Alright, and you should have a little bit of deflection. Okay, so you've got a little bit of deflection, which is all you need. Alright, so you know, just about probably 5mm deflection, that's all you need. But they don't need to be super tight, okay? Just enough so that this is not moving, okay? As you can see here, this is not moving. We then connect the control box onto the motor. Okay, it's one-way connection, it's got a clip in there. You just line it up like so. That is now lined up, and then basically you can just control the focuser up and down, and you can adjust the certain speeds. So now you can see the pulleys. I've got the control box. Okay, so what we're going to do is I'm just going to operate it so you can see the pulleys and the belt, how it works. Alright, so I'm slowing it down. So maximum speed. Forward. Now there's a slight little bit of slippage there, but that's not to worry, because all I've got to do is just tighten these up a little bit more, alright, and just give me a bit more tension. Even with the slowest speed and all that, as you can see there. As you can see, it's really good. So basically I just need to adjust it a little bit more, but as you can see now, the modification works really well and it looks like a professional job. So don't forget, during winter months or during summer months, you need to just tighten that belt periodically just to give it the correct amount of tension. That's why you have to file in these holes, make them elongated, so that you can adjust the belt in and out, so you can get the correct tension. So don't forget, this is not always going to be, this is not always going to be spot on accurate, okay, all the time. It has to be so that if it is cold at night, just adjust it slightly and get the correct tension you need. So that concludes my guide now. I hope you find this video helpful. Please feel free to comment, and again, we're also available on the Astronomy for Beginners Astro group, which is the Facebook group. If you click on that, if you check that link out, please visit us, please join that group. Okay, we've got a lot of good advice there from a lot of beginners and experienced astronomers alike. Okay, so feel free to join that group. Please feel free to subscribe onto my channel. We've got many more projects and reviews on astronomy equipment and techniques and tips. Okay, so please look forward to some more video guides, and again, click that button, hit the subscribe button, and again, thanks for watching, and clear skies to you all.